Why do we open, the reconstructed CT if the raw spec data, if we want to reconstruct the spec data? Why do we need that?
To avoid CPU. I don't know how to say. Am I wrong?
Okay, so the answer is really short. Okay.
Yeah.
For attenuation and scatter correction.
Oh.
Okay.
Oh. Or attenuation
and scatter correction.
Okay.
Okay. So because it is always applied, it will be also used for the PET reconstruction next week. So it is always applied for spec reconstruction because so the system or the algorithm need to know, where is the body and where is the air in the field of view, because it has to consider the volume in the field of view where the scattering and the attenuating event happens with the photons before the detection. Okay, because we have to correct this effect. Okay, so let's select first. Okay, the raw spec data and the reconstructed CT from this list.
看我操作吗？
Go. So 换人。
Just try to show me how to do that.
How to do
一共
this one?
Yeah, that's the raw spec data and
我们在哪？是 reconspect。Okay.
okay. Let's just please give it to me. So, so this is the study name we have created. And this is the study date, so you can use it as I don't know. It's a kind of parameter you can use for making the list. So to make an order according to the date you have acquired them. But what can also tell us more is the modality. Okay, so the nuclear medicine, the NM, which refers to the spec data, has to be selected. There is only one because we did only one spec acquisition, and there are a couple of corresponding scans in the CT modality. Okay, so we did a side view, a top view, a scan, and also there is a scan slices. So the scan always the raw CT data. So these are the projections, and the scan slices always shows us the reconstructed CT. So we have to select the raw spec data and with the control select the scan slices.
两个都要选吗？
Okay, and once more, why do we select both the raw spec data and the reconstructed CT? So what is the reason we need the reconstructed CT?
For registration, for the range, the spec, for the attenuation correction.
Yes, for attenuation and scatter correction. That's important. So they are already co-registered. Okay, so it's not something we need to handle. It's only for the correction. Okay, and once you have selected a raw data, you also have to select one of the processing protocols. So actually we can close the QM protocol and the service protocol, so we need to focus on the clinical protocols. And as you see, there is two options. So one is the high dynamic range and the normal dynamic range. So the normal dynamic range is what we usually use. A high dynamic range is something special. So it should be selected if you have a scan of an organ. For example, you are scanning only and you want the image only from the lungs or the heart or something, but you injected something which accumulates quite highly in the liver, for example, which is really close to your region of interest. So, but you don't want to include the liver, you only need the lungs. So this is when you should select the high dynamic range, because that kind of reconstructional algorithm can handle this kind of situation. So there will be no distortion of the reconstructed image caused by the high accumulation just in the really adjacent region, okay, in the animal. So let's select the normal dynamic range and say open. And open again. So some parameters are read out, but some is not. So for example, so sometimes we realize that even though you have filled in the weight of the animal, it is not appearing there, but it is in the it is in the header and it is stored and it is used, but it's not appearing there. So you don't really bother it. So actually, the first page is just a visualization of how the raw data look like, and also some image of the syringe itself from the reconstructed CT. So you don't need to do anything, just click next. Yeah, and this is actually the material map created based on the CT image. So it says that everything which is below minus 200 Hounsfield unit will be referred or will be considered as air, and everything which is above it will be considered as a body. So this is something you can edit. So yeah, I don't really use this frequently, but there are different types of tissues, and you can set up different kinds of threshold which the system will use. So it's much more sophisticated in case of the PET CT systems, because there is a range you can set up. It's only one threshold. So I don't really think it is useful. I mean, yeah, but if there is a really high attenuating object, like, I don't know, for example, one of our labs are using ultrasound machine during the scan, and it is a kind of metal material with a really high attenuating property, and it really results in a kind of distortion on the image if you don't say if you don't tell the system that it is a separate material with a really high Hounsfield unit, because otherwise, so if you set up in that way, it will really improve the image quality, so there will be no distortion. But I think that only cases like this, when you need to have a kind of advanced material map. So it does not worth to add a separate segment for adipose bone and lung and things like that, because so even though for like rodents, like mice and rats, so there is no